Hello everybody and welcome back to Kerbal Space Program, where I'm still a little bit confused about why we're doing this mission for Valentina's ice cream mining campaign. I don't know, she managed to convince the disciplinary committee and then managed to convince the mission planning committee. So I'm very confused. But this is the Ice Cream Maker 5000 here. This is what we are going to be sending up, and this is going to be a complicated launch. Reason being, we're going to have some severe control authority in terms of our reaction wheels. Like, insufficient reaction wheels. I feel like we might actually need some RCS on this thing. Which is unusual. It's very unusual. But, how big is this? That is quite big. That's quite small. That's about the size of RCS that we're looking for. So we'll just slap a little bit of extra reaction control monopropellant on there. And then we'll put in a few thruster blocks. Like, up here, probably. Actually, like, here. Yeah, that should do. So that'll help us have some authority, which will be nice. We need to check delta V's, or rather thruster weights, 1.42 and 0.75. I mean, we're going to be higher in the atmosphere, and this will be... I mean, yeah, it'll be slightly more efficient higher up, so maybe this works? I'm definitely a little concerned about it tumbling. Valentina's willing to take the risk. We don't have any way for her to escape if this fails. She's just donezo. Which is why we need to simulate this mission. This is going to be a simulated mission like our solar gateway launch was. If we make it into orbit, it will graduate into an actual mission for the sake of time. If we do not make it into orbit, then we are free to revert this and make changes. So, let's go. We're going to need to get this thing set up. Now, we do have the exploration upper stage on this, right? Yes, we do. This is a... this is technically not the exploration upper stage. This is an upper stage. Technically, it's just the space station stage. So, we should, as long as we get this thing into orbit, we should have enough DV. It's getting it there that's going to be the interesting thing. So we're going to take off. You'll notice I'm not utilizing RCS currently. I'm going to set our minimum science to 1.0. At this altitude, RCS isn't hugely effective, and I would rather not be using our very limited monopropellant. Our apoapsis is approaching 2 kilometers. I want it to be at least 5, and I'm going to do a very, very gradual turn here. Okay, let's get some level of horizontal velocity. Oof. Oof, I'm not wanting it to go this far. It's fighting me very, very hard. No, please. No further. No further. Hold here. 90 degrees. You can do it. This is a yikes. This is absolutely a yikes trying to control this thing. I knew that would be the case. SRBs, please get out of here. Okay. We should be able to control this a little bit more effectively now. Our apoapsis is 60 kilometers right now. Let's just try to pitch this over a little bit. Okay, I think we're fine. Not my most efficient descent profile. Our inclination is quite off. We're going to have to change our inclination to go to min-miss anyway, but I'm just going to adjust this slightly. I'm not sure if we need to be positive or negative, actually. We're still not quite at 70 kilometers. In terms of our altitude, that will start going up relatively soon. Just trying to adjust our inclination a little more quickly right now. Half a degree. This is probably close enough. We'll just burn right at 90 degrees now. We're going to have to adjust our inclination anyway, and I don't want to spend extra fuel on this if I don't have to. Okay, our time to apoapsis is currently going down. We're going a little on the slow side. Which is kind of to be expected given this payload. Our time to apoapsis should start going back up relatively soon-ish. We've still got another couple hundred meters per second to go here. Valentina definitely cut this one close. I'm going to turn RCS on at this point. Yeah, thrust to weight is still just a little on the low side here. Go ahead and just hold prograde, Valentina. We're real close right now to being in orbit. We gotta push up a little bit further. That's a yikes. Okay, we're gonna skip off the atmosphere here. I'm gonna turn the RCS off. And we're going to just have to skip off of the atmosphere. Our speed was just a little bit on the slow side. We shouldn't have any real issues with this, though. In theory. The major issue that we may have is electric charge, but it looks like we are doing just fine on electric charge. So we are just going to continue to warp towards the periapsis a little bit, as quick as we can, skip out of the atmosphere, and then circularize. Or head to min-miss if we have the opportunity. We're now going back up. We have bounced off the atmosphere. We'll be exiting the atmosphere momentarily. And we are out. Okay, we'll extend our solar panels. There we go. And now we will take a quick look at min-miss. Min-miss is currently here. We'll set that as our target. We're basically right at the descending node, so let me just add a maneuver there and see what we need to do. There we go, that'll do. So we probably want this to be on normal, not anti-normal, I think. We can be using some monopropellant for this. That's fine. Okay. So we want to burn this now. Or now adjacent. We're slightly late on it, So I'm actually going to get rid of that node, and we are just going to look at the ascending node and burn here until this is approximately correct. One degree to go. That's close enough. I'm not going to burn any more fuel than that. And we are going to need to head to Minmus. So the question is, when can we make that burn happen and actually get there? I'm assuming not over here. I mean, that is an encounter. Is it a good encounter? That is a good question. Is that a moon encounter? Yeah, that's a moon encounter. I think we're going to have to raise our periapsis here. So just a very tiny amount, something like that, would do more than sufficient. That is, of course, a pro-grade burn. We will slowly reaction wheel our way over to that. There we go. And we'll warp to that next maneuver. So very, very tiny burn. We do not need much here. Just going to get us headed over there with the RCS. Perfect. Okay. We are basically in position for this burn. We will go ahead and warp forward a little bit. We're going to drift, but that's okay. We'll reposition now. And that should be fine. Okay, so now we will head off to Minmus. We'll have to do it next orbit, so we will do it somewhere around... Probably not here. Somewhere around here would be where we'd want to do it. Of course, Minmus is this orbit. Ooh, that's very close. How's that looking? Not bad, not bad. Whoa, too much. Way too much. Okay, let's take a quick look at that. I want it to be about 100 kilometers, I think, over the surface. That'll do. We're going to have to make an inclination change for sure. I want it to be relatively equatorial and in basically a circular 100-degree kilometer orbit. But this is going retrograde right now, and the question is, do we want to go prograde? I think we'd probably do. So something like this should do. Okay. So we can go ahead and warp to that orbit if we can find it on Kerbal. There we go. We'll warp to next maneuver. This is, of course, a pure prograde burn. And we're facing almost exactly retrograde. So I'm going to turn the RCS on as we head over. We need to burn this at T minus 1 minute 15 and a half seconds. No. What am I talking about? 30 plus 15 and a half seconds. So 45 and a half seconds. Okay. And we're just going to position right up over here. There we go. And we'll warp forward towards 45 and a half seconds. So we want to burn right now. Actually, I want to burn on the node. About like this. So I'm actually surprised that this worked on the first launch. That's slightly shocking to me. We definitely want to adjust our inclination on the Minmus orbit, because I want this to be pretty equatorial. We should have plenty of DV to make all this happen, though. We cut it a little tight on the orbit, but we've got plenty of maneuverable DV, so that's fine. And then we are going to be just changing the inclination, circularizing, and calling that good. Of course, we're going to need to launch at least 2 more modules for this particular station. Oh, you know what? I was intending to rendezvous these in Kerbal orbit. I always forget to do that. Like, inevitably. I'm going to turn that RCS off for now. Ooh, that was too much. That RCS is super convenient. Stop! Stop, RCS. We're good. We need to go back to prograde. Okay, so... That's very interesting. I'm going to put this on stability assist right now. Okay. That's good enough. The RCS did the trick. Okay, so here we are going to circularize. Something like this should do the trick. That put the periapsis at 100 kilometers, pretty much bang on. The apoapsis is a bit off, so we're going to have to do a second circularization burn. That's okay. We're also going to have to change our inclination pretty dramatically. We're already basically in the correct position for this burn. So let's warp to that. This is 11 days out, which is fine, because we have more than 11 days before we need to do one of our next things. I know that's a complicated term, things. By that I mean one of our long-term maneuvers. Okay, and here we are. So we need to perform this burn. This is a pure retrograde burn. This is a 7 1/2 second burn. And so we will warp forward towards that burn. Right now. And of course, we are going to be refueling this a little bit later on. Technically, we overshot slightly. I want to push that up. I'm not going to use RCS because that will adjust our orbit. Okay, there we go. We'll push that up a little more. That will do. Perfect. And then we will just pull this down to 100 kilometers. Just like that. That'll do. This is, of course, a pure retrograde burn. We'll physics warp the turn. And also, we'll get over to the maneuver node. In theory. Nope, that was time warp. I wanted physics warp. Okay, I want to be on stability assist right now. There we go. Now this is a very, very minor burn. We'll warp to that maneuver. Oh, hello. We've got some gravity scans here. Okay, we'll grab those after this maneuver. Now, technically, we probably want to store this, right? We want to move this. We don't have scientists in this capsule currently. We'll keep it for now. Well, we will go ahead and get this burned in just a moment. Again, this is a very, very, very minor burn. I think we can get a little further. Ooh, that's real close. That will do. Very nice. Look at that eccentricity. I love it. Okay, so right about here is when we're going to want to change our inclination. We are currently at a rather wacky inclination. Now I'm wanting this to be pretty equatorial. So we're going to need definitely to change when we do this burn. Actually, this is going to be very interesting indeed. Now that I think about it. Because this is definitely a wacky angle that we came in at. Now, I want to do something kind of like this, but we need to remember that what we really need to be matching is the orbital plane of Minmus, which is this guy right here. So this is the correct angle that we want to be matching. This line here, which just faded out. That's going to make things rather interesting, to be sure. So we're going to need to do something kind of like this. Just wondering, yeah, that would do that number. Okay. I mean, that gets us closer. There's no doubt about that. But we probably want to be doing it sometime around here. Yeah, that gets us real close. Other way. Okay, that's about the closest that we're going to get here. So we need to delay this ever so slightly, I feel like. This is not quite the right timing for this. Ooh, that's incredibly close. Ooh, hello. It looked like this was correct. Okay, that's starting to go back up. 0.4 degrees inclination there. 3. I'm trying to get this exactly bang on, which is always kind of difficult. This is going to be a very finely tuned node here. I actually want to do that. Okay. It's incredibly close. That's going up. And so is that. So actually our timing is just ever so slightly wrong here. 0.1 degrees. Okay, need to go the other way. Ooh, that's awful close. We might have to do another burn here to just alter that ever so slightly. We just might not quite be able to do it from here. And yeah, radial is not going to be helpful in this at all. So, yeah, I mean, that's basically the burn that we're going to have to go with. So let's just go get rotated up over there. Real quick here. Freeze that physics for right now. Oh, it's trying to go to retrograde. No wonder. We'll freeze that physics again, and we'll try to go to the maneuver node. Come on. Pitch down. There you go. You know what? I'll just do that. It alters our orbit slightly, but we're going to be doing that anyway. Like, we're going to have to fix that. So we'll warp to that next maneuver. And we'll just change our inclination here. This is a 3-second burn. So we're going to warp a little bit closer. Okay. I'm going to start this burn about now. Because we don't actually technically know exactly when this node is. And we're just trying to push our inclination a little bit here. Now I'm going to go directly onto the normal node here. No, the anti-normal node. Do something like that. Okay, and this should get us to an inclination of 0.0 degrees. We just missed it. It was there very, very briefly. Okay. Then at the apoapsis, we can just push the periapsis back out. This needs to be a very, very minor burn at normal. I overshot it again. Okay, let's push back to anti-normal. Very, very minor. Oh, that's so fast. That is so fast. I'm gonna try one more time. Got it. Okay. At the apoapsis, we have one final maneuver to do here to put this into its final orbit. We need to push the periapsis up to be 605 if we can. Right there. 0.4 meters per second. We'll head over towards prograde. And then directly over to the maneuver node. And we will warp to that maneuver. And we will warp to that maneuver. Not in physics warp. There we go. Okay. So we will just push this out ever so gently. I'm going to warp forward a little bit more. This is a very, very, very minor burn. Wow. That is an eccentricity right there. I like it. Okay, that is a nicely equatorial orbit at basically 100 kilometers. And that is Valentina with her mining station in orbit. She can deploy her scanner now and perform her orbital survey. Stable polar orbit between 25 kilometers and 300 kilometers. Yeah, that's right. I forgot that it had to be a polar orbit. For that to happen, we will have to do a refuel, I think. Yeah, I suspect so. How much DV would it take? Hypothetically. And then we'd want to do something kind of like this. I mean, that wouldn't be too much, actually. So essentially, all we'd have to do is add a maneuver here. At that maneuver, we would just burn normal until we got there. We'd want the inclination to be at 90 degrees at that point. Be theoretically possible. However, that is a job for next episode. I'm going to go ahead and put a cut in here, and next episode, we are going to get this thing into a polar orbit, which I forgot we need to do. You can leave your offerings to the engagement gods in the form of likes, comments, subscribes, and bell ringings, and I will see you all next time.